Hi, so yes, I'm Arthur. Quick background, I used to work in the space industry for several years, and then I was working in a place in Canada for most of my career. Then I moved to work for some tech companies at Shopify, and then I moved to Barcelona. I worked at Adevinta and some other tech company later called the Yaetos Network. And through that, I was on the tech side of it. I was always in the data side of it, so data engineering, data science, data analysis. We're doing a bit of everything. So that got me a chance to see actually quite a few teams recreating from scratch their own software to deal with data. I'm sure you've been part of companies that have done that too. So I was thinking maybe that would be nice to try to do something without some of the limitations that you have within the company, means like limited resources or like focus on one specific application, but without trying to think to make it more generic maybe. So that's where I'm coming from. And so that project, it's about creating Python and SQL in SQL or Python data pipelines, and the name Yaetos, you can pronounce it the way you want. It stands for yet another ETL tool on Spark. So it is based on Spark, but not just actually. Now the name is not even relevant anymore, but that's the way it is. So what we're gonna talk about, the industry quickly, what is Yaetos then, and some of the concepts inside Yaetos. So what is a job, what is a pipeline, what is a manifest, or concept that you probably saw before, how to set it up and test, how to go from prototype to production, how to handle job parameters, what's the typical workflow, some of the features, what are the Python libraries that are involved in this, because something that I mentioned that makes it a bit relevant to this meetup is that it is 100% Python pretty much, everything inside, and the demo. And just maybe a quick question, is there a lot of people here, by a show of hands, that are involved in data in their day-to-day job, as in like data engineering, data science, part of data teams, or, okay, so there are quite a few, so I hope it will speak to the others too, because in the end everything is data, and we should all try to learn more about some of those other topics. So, the industry, welcome to the jungle. There are tons of tools out there. I'm listing some of them, but you have different engines. You have, like, let's say, Redshift, Snowflake, Spark, Pandas. You have different system for storage. You have a different system for scheduling, for dependency management, cataloging. You have different data architectures. You have different tools to write your transformation code and try to orchestrate a bit of everything. Some of those tools, they encompass different of those concepts. So let's say Redshift, it has the SQL engine as part of it. It also takes care of storage. It can also do some scheduling, but in some cases you need to tie in some of those tools with another one to deal with dependency management. So it's always a bit of a Lego block. And so part of the motivation was try to have something that helps you deal with all of this. And some trends that I see in the industry in all of this. Overall, I think it is going towards more open source, which is good. It's part of the reason why we're here. Sometimes hosted as SaaS, which makes it even easier to set up. It is going towards more use or better use of software development best practices. I think for a while data was kind of on the side of software development practices, using some big proprietary solutions that were more maybe drag and drops, and then they would not integrate well with Git, with CI/CD, with all those things. But slowly, I think it is going in that direction. So that's good. It is going towards more self-serve and towards more Python, in the sense that quite a few of those teams, let's say for example Airflow, some dashboarding tools, quite a few of them now they're like 100% Python. So that was what I see as positive trends, and then some of the trends that I wish or I think will materialize eventually, but maybe it takes more time. For example, here I'm hoping more companies adopt the Datalink architecture. From what I see, you tell me if you think that's not right or that's not what you see. But quite a few, it's typically the bigger companies with more data that use this kind of architecture, data lake. But personally, I think it's amazing and it brings quite a few benefits, even for smaller companies. So I would think that in the future, slowly, people would get more towards this kind of architecture. And by data lake here, I mean like a file system, so S3 or local file system. And feel free to tell me if you disagree, but that's the way I see it, at least for now. So I see quite a few advantages to this, to have more flexibility to organize your data in terms of the cost of operating. It's about as cheap as it can get. It's at least a lot cheaper than typical databases to store your data in S3, for example. It's more flexible to store non-structured data sets, things like this. Some of the trends I wish would materialize more, maybe, have more hybrid SQL coding environments. So giving you more flexibility to overcome some limitations of some BI systems. And by that I mean like quite a few of them that are meant for 100% to handle SQL. But if they want to do some other things that require maybe a bit more coding, then sometimes you're limited to the SQL environment. And also to cover BI and data science use cases, all that like within one framework. And basically from what you see there, both of those items, they are very much in line with the Databricks vision. So Databricks, the initiator of Spark. And yes, it's definitely true, and I think they're doing an amazing job. The only limitation that I see with what they provide typically is the fact that for quite a few smaller companies that don't really have big data, they see Spark and Databricks as like a bit overkill. They think it's just too much they still want to automate data processes, but they don't need to handle partitioning and all those kind of things. Okay. And so for this, something that would be nice is like something that integrates also some lighter weight engine than Spark. So it could be Pandas, it could be other things. But that's basically the frame of mind that led me to do things the way I did it. So then, what is Yaetos? So an open source tool for data engineers, scientists, and analysts to easily create pipelines in Python and SQL and put them in production in AWS. So the goal is not to redo some of the things that are already done, but just to integrate some of the tools and to try to create the glue to integrate all those things and to make it easier to play with all those things. So it integrates all the tools necessary to create the data stack. It only relies on open source engines, for example, Spark and Pandas, and hosted services. So in that case, for example, it's built in the way that you shouldn't need to ask for a DevOps person to help set up a machine, to host some third services, for example, Airflow or some other ones. So that was the requirement for me as part of the project. And that's something that I studied actually a long time ago, about 3 years ago, as part of at the INTA. They didn't have this kind of stuff, or at least in the area where I was, in the department or at INTA Spain. But they wanted to get in that direction, so I studied that as a proof of concept. And then we started to use it in production there, and then I moved to another company, and then we were using it for all the BI related stuff. And so it's been in production, handling more than 100 data sets daily for more than 2 years now. But I never did any marketing or any promotion on that project, so it was just me on the side and some other people internally inside the company using the tool. But that's part of the effort now, is to try to see if it can be useful to others. Okay. So, in more details, I'd like to see it a Swiss Army knife, and quite a few benefits there. They come directly from the fact that it integrates Spark. So a lot of those things come for free, so then I just benefit from that. So for example, in terms of input, the goal is to be able to, with one consistent system, to be able to attack different sources. So it could be a data set on disk, on S3, in local. It could be unstructured data on this, let's say images, things like this. It could be tables in MySQL, in Postgres, in Redshift. Those are all things that I've done as part of the tool. Or API services. So, for example, I had some jobs, and actually there are still some jobs in the previous company that extract data from Salesforce and Stripe and do that every X hours and then integrate with other data sets. So it's part of those things that are done. And when it comes to output, pretty much the same thing. When it comes to the core of it, the engine, so the core of it is Spark. Now you can use Pandas, but Pandas is not as well integrated. But for basic use cases, it's fine. It's there, it works. And then for resources, it integrates with AWS EMR, so the Elastic MapReduce from AWS. And for scheduling, it integrates with AWS data pipelines. So basically, those are hosted services from AWS, and you can get it set up in minutes. All you need to do is put your credit card, and that's pretty much it. So the limit is your budget. And the goal is to make it with some room for expansion. So, for example, good candidates for addition. I said that for resources, it uses the EMR, which was the first system that Amazon was providing to create like a cluster in the cloud. But now there are some of them that are pretty popular, that are used by a lot of startups or tech companies, like Kubernetes. So, for example, the ability to integrate with Kubernetes, that would be obviously a good candidate. Or AWS Lambda. In the previous presentation, you were seeing that it was part of the architecture too. And for scheduling, when I started, AWS Data Pipeline was the only tool, at least that I knew at the time, that would allow you to schedule stuff in the AWS ecosystem. But recently they added AWS Airflow, so Airflow hosted by AWS. And so now you could think that you could like easily integrate with AWS and have another scheduling option that's maybe closer to some of the people are using in the industry. Next. So, definition of a job. So, basically a job is just a file that takes some different inputs and that outputs typically one data set, but it could be more, and it could be not just a data set but other things, but typically one data set as an output, and it can be expressed in different ways, and that's part of the goal, is to be able to offer different options. So depending on the case, you can set it up differently. So basically the first one is just .SQL file. So here, it's just going to be SQL, and it's going to run on top of Spark. And so you let Spark do its thing, and you don't even need to know Spark, you don't need to know any Python. All you need to know is SQL and some YAML, because of some other YAML file I'm going to show after. But you can get up, let's say, as an analyst that maybe doesn't have much experience with Python. You can get up and running without knowing any Python, basically. It's just pure SQL, which more people know overall. And then you can do the exact, here, those are, this is the exact same transformation, 3 different times, but just to show that you can do it in different ways and to show the trade-offs. So here, for example, you use the framework, and it takes a bit more code, but then you have access to the full power of Spark inside, because then you can use all the API from Spark, you can use all the libraries from the Python world, you can integrate any other library, you can integrate scikit-learn, TensorFlow, all those things. And then the last one, where you don't even use some of the helper functions that were created as part of the framework, but you can still do it that way and create the Spark context yourself and create load the files yourself. Don't use the framework that helps you with some of this, and it gives you again more flexibility, but it just takes more code to write. Okay. And so now more details into the specific job, and that's the one that I would use the most. So basically, what you need to do to use it is to import those two classes from the framework, and that you need to have a class that derives from that base class, and you need to use that command liner that's gonna deal with all the command line related stuff, and also execute the job itself. And the job or the pipeline if there's dependencies and stuff like that, which we'll see after. And then inside, you just need to give it the input data sets, and they will be loaded for you. And you'll see right after where they will be loaded from. They will be loaded for you, and they will be passed as a Spark data frame or as a Pandas data frame, depending on how you set it up. And then inside it could be a SQL, but it could be anything, any of the Spark data frame stuff, or also Spark RDDs if you wanted. So it has this kind of flexibility. And in terms of parameters, you have a whole bunch of parameters that you can set to help push code to Redshift, like things like this that are not for you. The goal is to help you not have to write some of the boilerplate code. And here in that case, the parameter is pretty much just pointing you to another file that contains more parameters, that we will see right now, because it's the other important concept of that's the part of the manifest. So job registry or jobs metadata, and that's this kind of YAML file. So that's the job manifest, and this is a registry of all the jobs that you have with all the important high-level information about each job. So here you have an example like 3 of them, but it could be literally hundreds. I've seen in some companies actually like close to 1,000 or something. And here we have an extraction job. So you see inputs, it's grabbing some data from Wikipedia. We have some SQL job here. So you see inputs, outputs, dependencies. This one depends on that one. So to be able to execute that, you can tell it, please execute the dependencies, and it will go and execute that one first. And same thing for another one, that's another Python job, for example. What else? And then, like, basically that relationship between the two, you're in the end, when it comes to your like having to program data pipelines, you're always switching between your job file and your job registry file. So, for example, let's say the first one. So you see that's a SQL file. So you see the name. That's the name that matches there. So that's how it recognizes it. And then those two inputs that I use for that file, it's called some events and some other events. This is where you can see the definition of where this comes from. So this comes from that path, and that path can be changed dynamically, whether you're running it in local or in S3. And so normally you don't have to worry too much about that. You set it once, and then everything else should be consistent, and it will be pretty much the same path, whether you're in the S3 world or whether you're doing it locally. Yeah. So similar thing for example for a Python job. Here you have the name that matches the name of the job there, and again you need to specify the two input data sets, some events, other events, and here that's where they will be taken from, and the output is going to be dropped directly in there, and you see like the use of those latest, now, and those are helper tags, like Airflow has similar concepts, I think, that allow you to put timestamps and to automatically get the latest one, for example, things like this. So you don't have to, the goal is to not have to update your path for every little change that you make and any new generation of the data set. Yeah. And last thing, for example, a pandas job, so exact same thing, the only thing is that here, as part of the definition, you would set the df type to pandas, and in that case, it would load it as a pandas data frame as opposed to a Spark data frame, like this. But the goal is that all the rest should not have to change, it should be like a somewhat consistent and clean interface to you. And definition of a pipeline, well, that was the last concept, but it's pretty basic. It's just a job running with its dependencies, and we'll see how later how we run that. And now how to get it set up. So what you need to do to get it set up is to just run this, pip install Yaetos, then create or run Yaetos Setup project, and you give it the name of your project, and it's going to create, just like web framework, it's going to create a folder with a bunch of files in there that will help you with setting up some of the things, and it will provide with 3 different sample jobs that are already created just to test it quickly, and jobs that rely on Wikipedia, free data, just to make it easier to understand how things work when you run it. And then, so since you have some sample jobs directly in there as part of the setup, you should be able to do cd directly to your folder, launch Yaetos Docker bash, so that would bring you to the bash environment inside that Docker, and that Docker has everything set up for you, the Java and like all the Spark stuff, and the libraries. And you should be able to just do Python and your job, and that's it, and it should run locally. It should use the Docker environment, but the input and output will be outside of your Docker environment on your host OS. And same thing for a pipeline, so same thing, but you tell it, please run with its dependencies, and then it's going to check all the dependencies and dependencies of dependencies, and
sorry,
yes.
can I ask you a question?
Yes.
So you said you're running inside the Docker, but you're outside. So you're handling the Python environment inside the Docker. Can you explain me a little bit?
Yeah. So here, yeah, maybe it could be made more made clearer. Here, once you do that, you end up in a new environment inside that terminal. That would be your Docker bash environment. So in bash inside Docker, and you can run it inside the Docker directly. So here it's not the same terminal environment directly. Here you're inside, you're in the host OS and the guest OS.
Okay.
Yeah. But actually, since you're speaking about that, you can also ignore that, and you can, without having to go inside Docker, you can say Yaetos run Dockerized this, and that would be the same thing. So it would use the Docker environment, but without having to go inside the bash environment inside Docker. Okay? And then where does it live? I was saying that it's going to create a folder with some of the files. So this is what it would create. So it would create like the job metadata file, so that manifest that I was speaking about before. It's going to create some AWS config file that will be empty, but I mean telling you what you need to put in there. But then it's up to you to go and check in your AWS environment where to get it from. If you have this would be your secret file. So whenever things run on the cloud, if you're or running locally, if you need to get interact with services that require some credentials or tokens or things like this, you can put it in there, and it will be handled separately from the rest of the code. You would have those are the 3 sample jobs, and you have some unit tests for some of those sample jobs. Okay, so here, for example, unit tests. That's something again like I think something that comes from the software world. That's not often done in the data world, but I've seen it done in previous company. I thought it was pretty useful, so I integrated it in there. So here, what I mean by unit test, it's really just like a normal software development unit test, as in you give it the expected inputs, like 3 lines of 2 different data sets, for example, that you need, and you tell it exactly what you expect as an output. So typically just like a few lines and a few columns, and then you can validate whether your code meets that or not. Okay. And then when it comes to inspecting the job, so far we were only speaking about running things in a command line in a terminal. But if you want, you can also do it in Jupyter. For people that come more from a data science background, they like working in Jupyter, and it's feasible, and it's part of the Docker environment as well. Okay. And then going from prototype to production, as I was saying, the goal is to simplify all this kind of stuff. So here, once you're inside Docker and you run your Python, this is what we've seen before, to run something locally on your laptop. But if you want to run it on the cloud, all you do is just add deploy EMR, and in that case, it's gonna create an EMR, create the resources online in AWS, push the code over there, execute, and dive when the job is finished. And same thing if you want to deploy in the cloud and on the schedule, you would put deploy EMR scheduled, and assuming that you have in the YAML file all the scheduling related information, like how often it should run, this kind of stuff, then it's gonna do this. Okay? And actually I go into a bit more details right after for those three modes. So that's the basic one. When you run something locally, basically it's using the CPU for your machine and your file system. If you run in the cloud, then it's gonna zip your code inside that folder, push it to S3, send the secrets separately to a separate service to make sure we don't mix the secrets with the rest of the code, and to make, for example, it's, to make sure, for example, that they don't show up in the logs and those kind of things. It's going to create the EMR, load the inputs, process everything, repeat with the next dependent job if any, and then the cluster will just die. So that's how you would execute the job in the cloud, and I can just demo it quickly right up. And if you want to run something in the cloud and on the schedule, same thing, but in that case it's going to add to the mix AWS data pipeline. Well, as soon as you put that EMR schedule there, it's going to push the code to S3 and at the same time set up that tool, so the next time, let's say beginning of the day at 7 in the morning, then, only then, it's going to create a cluster, execute your thing, and create the new data in S3, and maybe push it to a Redshift or some other things, and die. Okay? And basically, what you have in the end, if you have a bunch of pipelines, that would be a scheme like this, where you have some pipeline that run, let's say, twice a day, that takes this amount of resources, and then you may have another pipeline that runs only once a day at a specific time, and you may have a pipeline that takes less time, and basically for each one of them you can set a different parameters for the cluster. You can set a different number of machines. A cluster could be one machine, it could be 10 machines. Again, like your budget will dictate how often you want to get your, or how fast you want to get your results. And then when it comes to checking the results of what's happening in the cloud, since it just integrates directly with those tools in the cloud, you need to go to AWS to be able to monitor all those things. So for example, when you're creating some EMR and you want to check something there, you want to check the logs and things like this, you would go to AWS and check the resources, the EMR section, and this is where you would be able to dig in which cluster you're running and things like this. When it comes to the storage, so your data lake, you would go to the S3 section in AWS, and when it comes to all the scheduling things, if things are running as expected, if things are successful when running on the schedule, you would go to AWS data pipeline, so that's scheduling service from AWS. And for example, here there is only one pipeline running, and you can see that it's running, it's green, so it means as of today, it's fine, it's working well. And if you click on it, then you can see the details of all the previous executions. So if it runs 4 times a day, you would see 4 times a day, and you would see whether some of them failed or things like this. and just like Airflow and some other frameworks, it would handle retries and things like this. Okay? And I was speaking about job parameters before, and just to mention that there is more stuff that I didn't get into. So I mentioned, for example, the inputs, outputs. That's the pretty obvious one. There is more stuff that can be done. For example, there is one that you can add that's called copy to Redshift, where you give it what section of credentials from your password file you need to point to, and where to put that data. And in that case, you wouldn't need to write any other code. As soon as the framework is done processing the data, it will also push that data to Redshift, so it could push as an incremental addition to the data set, or it could push as a replacement of the previous data set. It's part of the thing you can set. What else? When it comes to the cluster, that EMR that you are setting up, you have few parameters where you can tell it the properties of that EMR. So for example, what kind of EC2 instances you want to run for this EMR, how many machines in your EMR. So you can have, as I was saying, one machine or as many as you want. So technically, you could literally process petabytes as long as you have enough money to pay for all the machines. And I was thinking about scheduling information before. So this is the way that you specify the scheduling information. So let's say frequency 1 day. Every day we need to run it. We can start at 7 in the morning. And you can tell it to start from some date in the past. And also you can specify some emails to be able to send emails if it failed while running in the cloud. And one last, here it says some job specific parameter. So here is just to show that the way it's handled is very flexible, so you can create any parameter on the spot right there if you want, and capture it inside your job, and you don't need to specify anything else. You don't need to register parameters, or you're not limited to the set of predefined parameters that I'm using, but you can create your own, and it's been useful for me quite a few times. When you have jobs, for example, that do things depending on the country, you can set the country as a parameter, and in your job parameter file, you say, okay, run this one for this country, this one for this country, things like this. Okay. And so the typical workflow, ideally, you write your unit test, but in the data world, I don't know any team that does that. But technically, with this kind of framework, you could. And then you can write your transform locally and check if you pass your unit test, or check it with some local data that you have in your machine. You could actually technically do more, and I've done it in the past. You could also, for example, from your laptop, connect directly to the data in S3. You can do that, but then it's a bit slow. If the data is big, then it's not really an option. But it's feasible, partly because Spark handles that. Then, once things work well locally, then you can test it in the cloud using the extra arguments that I was showing before. Once you're happy, you can create your PR in GitHub, merge, and deploy to the scheduling tool using again the same arguments that I've shown before. Okay. And I won't have time to go through everything, but just like some other features quickly. So overall, I think there is fairly clean logs, just because the framework handles like loading your data and pushing your data to S3. Then it has visibility of or it can infer all the field names, field types. So it puts that into the log. So the logs, you can quickly see all the inputs, the field types, field names, all the configuration for Spark, like a whole bunch of things that come for free as part of the framework. It handles the secret in a fairly clean way, I think. It helps with automation of the folder structure. There is some support for idempotent incremental pipelines. And by idempotent here, we mean the fact that if you rerun the same job, it won't duplicate your data just because the job has already been run that same day, for example. It will know that this data has already been processed, and so it doesn't need to reprocess again. It supports some GitHub's operation in the sense that it's going to prompt you if you're trying to push code that has some local updates. And it's going to, for example, put the git hash into the log too, so you can train those things. It's going to infer some schemas and also create some YAML files inside your folder. It's going to create like a schema folder where it's going to use the same job like structure, and it's going to document all the YAML files. And so if you put that in Git, then next time you make a modification and you rerun it locally, you would see, okay, like there are some new fields or some fields that change names and things like this. Okay. Unit testing, and it supports, for example, saving and loading ML model files, or could be ML models file, but it could be just any binary file basically that you either drop in local or in S3. And in the main repository, there are more example jobs than the 3 that come when you do the pip install. And since it's all Python here, I thought maybe people would be curious to know what are the main libraries used inside. So in that case, all the AWS things are handled by Boto 3, which is like the main library to interact with AWS services. AWS CLI for authentication to AWS, CloudPath lib, SQL Alchemy to deal with external databases like MySQL and things like this. PySpark, Pandas, NetworkX to build like the tree of dependencies across jobs. YAML, PyYAML, and PyTest for unit testing. Okay. And then inside the job code, as I was saying, it's flexible. You can add whatever you want in there. So in my case, I've already used like PyMySQL to connect to MySQL, connectors for Postgres, Redshift, connectors to Salesforce, to Stripe, and some stuff to read Excel for some clients. And quick demo. Okay. So, what do we have? Okay, so basically here we have an empty folder, and actually have, it should take like 2 or 3 minutes.
Yeah, we are near, well, we are already a little late on time.
Okay.
So maybe wait.
Is it okay in 2 minutes?
Okay.
Okay. So basically, what you would do, pp fold Yaetos, here it's already done. Let's say, boom. So here we just created that folder that we saw there. So this is the folder with the main parameters. And here you can see, for example, the job metadata file. You can see the AWS config that I was telling you. So those are the parameters that you would need to grab to be able to push things to the cloud. So in that case, I'm going to run it. Let's see, cd Yaetos. Oh, no. Okay. I'm going to run a job locally, and then I will run it in the cloud just to. So when you run that job, so it's just an extraction job pulling data from Wikipedia. So you would see all the parameters that are used to create that job. It's loading everything inside Docker, and starting running that job. It's telling you what are the inputs. Actually, in that case, there are no inputs, but what's the output? It gives you like the top 20 rows just to get a general sense. Output count, the field types, how long it took to run it, where is the output. So it created that folder directly, and that's it. And then if you want to create it, to run it in the cloud, what you would need to do is set up that AWS config file. So in that case, I will just take the setup from boom, and let's see if that works. And so here that would be the same. Oh no. This is easier with the microphone on the other hand. Yeah, that's okay. That's okay. Okay, here it is. So basically here we are telling it it's the same command, but we're just adding like deploy EMR. And so in that case, we'll see no cluster found. I will create one. So it's starting a new cluster. And so if you check in your AWS environment, so if I refresh here it is. You see that right now it's starting a cluster, and it takes like 2 minutes or so to boot, and it's gonna push the code there, execute, and die. And you can also give extra argument to tell it please stay live, so you can you don't have to wait for the booting time, and you can just push new jobs to a current cluster. Or for example, if you already have a cluster, you can tell it, okay, I'm re-executing the same job here. And here it's going to say, okay, like I see that there is a cluster already live. Do you want to execute on a different cluster or on the piggyback on the previous cluster? And here we're going to tell that. And that's it for the demo. And what else? What else? Yeah, so just more details. Those are the repo and the Medium post that I wrote on it. And if you found it interesting, feel free to help make it more visible by putting some star in the repo, and feel free to get in touch. And there is tons of room for improvement. So any help, thank you very much.